My project in this presentation is on click-through rate prediction. The business problem is in any type of advertising, including online advertising, the click-through rate, or CTR, is a very important metric to evaluate performance. Due to this, click-through prediction systems are a must-have and used quite often for sponsored search and real-time bidding. In this case, there was 11 days of data provided in order to build and test prediction models to come up with the best performing model. In this case, I ran multiple models to predict if a user would click on a mobile ad or simply click through. There were multiple variables used to determine the prediction. Some of the variables, including the hour of the day, the position of the banner, information about the site, information about the application, information about the user's device, and various other categorical variables. I ran 6 different types of models and documented the accuracy for each of the best performing models of that type. As you can see from the table I'm going to show you on the following slide, the accuracy ranges from 79% up to almost 83%. The models all performed fairly close as far as accuracy goes. The top 3 models with over 82% accuracy were SVM, logistic regression, and boosted tree. The following slides show the different type of models used as well as the parameters arguments passed in. And the last slides in the PowerPoint discuss some of the other observations that were noticed. Again, here is the table of the models used, and you can see the different models and the accuracy. They all performed fairly similar, with the boosted tree just being slightly better than the logistic regression, which was slightly better than the SV. The different parameters and arguments that were passed in, you can see for SVM, it was the kernel poly with the degree 3, and C equals 1 was the best performer. For the cart, it was just the decision tree classifier. For KNN, it was the KNN with the nearest neighbor of 2 and the metric of Euclidean. Logistic regression was the penalty L1 performed the best. And then random forest, the estimators of 15, and the boosted tree, the gradient boosting, was the best performed. Some of the other things that I discussed earlier were the clicks per site category. This was one that stood out, that was interesting, and you can really see there's probably about seven site categories that contributed to the majority of this, really. And then with the first category there contributed to over 24,000 of the clicks. We also had clicks per app category. Again, you can see it's about 5 of the app categories contributed to the majority of the clicks, with one in particular being over 50,000 clicks. So I found that interesting. And then here we have clicks per site. There's about 6 different sites that accounted for the majority of the clicks, with the biggest one being over 22,000 clicks for that particular site. And then the last observation was clicks per banner position. This one I found very interesting. There were about 5 different banner positions, and 2 of the banner positions, meaning where the ad sits on the page, were the most important. And in fact, one of them accounted for over 50,000 of the clicks. So you can see that the banner position has a huge impact on whether those ads are clicked on or not. So I found this one very interesting. And then in conclusion, you can see that we can predict with over an 80% accuracy rate whether a user will click on or click through a mobile ad. You can also see from the previous 4 slides the different observations and the impact an attribute might have on whether an ad is clicked. Obviously, the site category, app category, and banner position play a big part in this. And I think the most interesting piece of the information was the banner position, how important that is in whether those are clicked on or not. And then you can see how those all play a big factor in whether they click on the ad or click through the ad.